This is definitely a major achievement, because here the study addresses a fundamental question in physics. So where exactly does the quantum world end and the classical world begin? And well, the thing is, there seems to be no answer right now. By showing that these massive particles can become quantum, researchers confirm that there is currently no observed mass limit. As a matter of fact, if once again you look at this graph here, you can kind of see a progression line that just keeps getting higher and higher and higher, which of course paves the way for even more ambitious experiments or possibly new physical models that have to try to explain where this quantum effect breaks down or whether there is a limit at all. As a matter of fact, in the last few years we've discussed some really intriguing propositions in regards to quantum effects, such as one interesting proposition that the microtubules inside our brain might also experience a lot of quantum effects and thus create the idea of consciousness. You can learn about this somewhat controversial topic in one of the videos in the description, but this is of course one of many reasons why this experiment is so exciting. And you can actually see some of the other experiments we discussed previously in this list as well. For example, the green square you see here, this is another recent study involving the collective quantum motion of 6 microscopic mechanical oscillators, or basically 6 tiny drums. And in this case, by cooling down these drums to very low energies, researchers allowed them to achieve their ground state, which then created a somewhat bizarre effect. Instead of each of the drums moving independently, all 6 drums actually entered a unified collective state, vibrating at the same time as a single quantum entity. With additional experiments in 2025, using slightly different drum heads, and something that was even larger. And surprisingly here, these drums were even able to maintain their quantum connection, even in the presence of environmental noise. Normally this would destroy these quantum states, but in this case it didn't. And so here these drums were able to maintain their quantum connection indefinitely. It was reported in the study you can find in the description, and these drums essentially resembled something like this. And because of these experiments, we can now actually start tackling other questions involving questions in astronomy and biology that sometimes relied on these quantum effects or macroscopic quantum effects for a potential explanation. For example, in astrophysics, some theories involving gravity and dark matter actually use quantum mechanics and quantum states and the collapse of these states to explain certain effects we observe around us. For example, the idea behind dark matter is sometimes explained with the principle known as axions. And here these superlight axions would actually be these quantum waves oscillating across the universe. Now we've discussed one of these explanations in some of the videos in the description, but the point here is that maybe these quantum effects don't really have any size or mass limit and can actually occur on extremely large scales.